Okay, so this is problem 563, and it's a problem that has to deal with an aircraft here, and there's an unequal distribution of fuel in the wings tanks. So the fuel in wing in B here is 8,000 pounds, and C here it's 6,000 pounds, and kind of the fuselage A here is 45,000 pounds. And what we're looking for is the reaction forces at the wheels. So the wheels are located at D, E, and F. And I think, you could do this problem in, IJK components, but in this problem, I'm going to break it down into using kind of 2D and clockwise, counterclockwise moments here. So I've drawn kind of a 2D cross section of the plane looking straight directly at the nose here and labeled the forces. So we have the forces on the wings here, as well as the force of the fuselage and the spacing of each one of these forces in terms of feet here. And so to do this, we're going to do the sum of the moments around x and set those equal to 0. So the sum of moments around x and set those equal to 0. So you can see the x-axis is actually pointed directly at us here. So we're taking the moments kind of about the x-axis here. All right, so the moments about the x-axis are equal to 0. All right, so to do this, let's first talk about the known forces. So we have 8,000, and that's going to create, I guess we need a sign convention, positive counterclockwise. 8,000 is going to create a positive moment. So we have 8,000, and the distance it's acting away here is 6 feet. So 6 feet. 45,000 goes directly through our x-axis, so it's not going to create a moment around the x-axis, so we can ignore the 45,000. And then lastly, 6,000, which is going to create a clockwise moment, so it's negative 6,000, and the distance it's acting away is 8 feet here. All right, and then we have the moments of the support forces, the unknowns here. So NF goes directly through the x-axis, so it's not going to create a moment around the x-axis. So we need ND, and ND is going to create a clockwise moment, so that's going to be negative ND times 14 feet. And then NE is going to create a counterclockwise moment, and the distance it's acting away is also 14 feet, and that is equal to 0. So we have two unknowns in this equation, and just one equation. We can't directly solve for anything yet. All right, so let's move on, and I have the second schematic here, the second free body diagram, and we have kind of looking the other direction, looking directly down the y-axis here. So we're going to take the moments about the y-axis and set those equal to 0. So since our y-axis is right here, we have ND and NE are directly acting through that, so it's going to create no moment there. So let's first do the known forces. So 45,000 here is going to create a counterclockwise moment, so that will be positive 45,000. And the distance that's acting away is 4 plus 3, which is 7. Okay. And then we have the combination of the wings, and I put them as a single force because they're directly on top of each other here. So that's 14,000, and that's also a positive moment. 14,000. And the distance that's acting away is 4 feet. And then the unknown that we have is NF, which is acting 27 feet away from 27 feet away from the y-axis. Okay, and that's going to be clockwise, so that's going to be negative. So we have NF times 27, and that's going to be equal to 0, right? we can solve that directly. So we have NF, NF is equal to 13.7 kips. Okay, so we still have two unknowns that we need to solve for, ND and NE. We only have one equation with those in them, so we need one more equation here. So what I'm going to do is the sum of the forces in the z direction and set those equal to 0. So we have all the normal forces pointing upwards, so those are all going to be positive, ND plus NE plus NF. And then we have all the downward forces, which is 45,000 and 8,000 and 6,000, I believe. Yeah, 8,000 and 6,000 also acting downward. So we have negative 8,000 and negative 6,000. And those should all be equal to 0. This entire equation should be equal to 0. It's in equilibrium, so the sum of the forces in the z should equal 0. And through subbing in for using this equation here and solving either for NE or ND, we can substitute into this equation. And the solution we get is ND is equal to 22.6 kips. Remember, a kip is 1,000 pounds. And NE comes out to be 22.6 kips as well.